Hello dear, welcome to my YouTube channel. Since you have decided to go with this video, now it's my responsibility to make you exam ready. At the end of this video, I promise you 5 marks out of this topic relations in the upcoming semester 1 of ISC 2022. So keep calm and keep watching. We are going to divide this whole unit 1 into 3 subunits. First one is relations, second one is functions, and the third one is inverse trigonometric functions. Contribution of the first 2 subunits will be 5 plus 5, that is 10 in total, and the contribution of the third subunit, that is inverse trigonometric functions, is going to be 10 alone. So total 10 plus 10, 20. In this video, we will cover the first subunit, that is relations. To make it easier to remember for all of you, I have divided this whole theoretical discussion into 5 subparts. In the first 4 parts, we will cover all the theoretical discussions, and in the last part, we will solve few important and different types of MCQs. In part 1, before going straight into a relation on a particular set, we must have the idea of these 4 basic terms about set algebra. First, cardinal number. Cardinal number is nothing but the number of elements in a particular set. Suppose a set, for example, is given by A is equals to 1, 2, A, B. Then n of A, that is the cardinal number, it is represented as n of A, is 4 in this case. So cardinal number is simply the total number of elements in a particular set. The second point is the set builder form. Any set can be represented in 2 forms, a set builder form or the roster form. For example, we are considering squares of natural numbers. That set, suppose we represent it with B, then that set, that is the squares of natural numbers, will contain infinite number of terms because there are infinite number of natural numbers. So the elements will be 1, then 4, then 9, then 16, and so on. But this set can be represented very simply with the use of set builder form as x is the general element of this particular set B, such that x is equals to n square, where n belongs to capital N or natural number set. That's it. Now the next topic is Cartesian product. Product means multiplication, and here we are considering the product of 2 sets. Sometimes we call this as power set. The Cartesian product or the power set of 2 given sets is written in terms of ordered pairs, that is the 4th point. This ordered pair is a combination of 2 elements where the first element is taken from the first set and the second element is taken from the second set, and this combination will be called the ordered pair. So for example, we have 2 sets A 1, 2 and another set B, it contains elements A, B. So in this case, the Cartesian cardinal number is 2, and that for set B is also 2. Now to multiply these 2 sets, we need to follow the Cartesian product rule. What does it say? If we are finding A cross B, all the elements of this power set will be ordered pairs. Ordered pairs means a pair of 2 elements written in this way or in this format, such that A belongs to the first set and B belongs to the second set. What will be the number of elements in a power set or Cartesian product set? The answer of this question is the number of elements or the cardinal number of a power set is simply the product of the cardinal numbers of the two sets that we are multiplying. So in this case it is going to be 2 into 2, that is 4. Now what will be the elements of the product set A cross B in this case? So if we follow the definition of the Cartesian product, we will be able to write these 4 ordered pairs. For example, they are 1 from the set A and A from set B, again 1 from set A, B from set B, 2 from set A from set B, and the last one 2 from set A and B from set B. These are the 4 ordered pairs when we will multiply these two particular sets A and B. Now we are all set to discuss the main topic, that is the relation on a set. First of all, relation is nothing but a subset or equal to a power set. So it can be the power set of two different sets or a single set. In our ISC syllabus we have this thing only, that is we are going to define the relations on a particular set. For example, consider this particular set A given by the elements 1, 2, 3. Now if we try to find out the power set A cross A multiplied by A itself, then what will be the ordered pairs? First element 1 from set A and the second element again from set A, that is 1, 1. Next the first element 1, second element choose a different one, that is 2, then 1, 3, again 2, 1, 2, 2, 3, and the last 3, 3, 1, 3, 2, and 3, 3. That's it. These are the all possible ordered pairs of the power set A cross A. Is it true? How to check it? When it use the cardinal number rule, that is the cardinal number of A is 3, so the cardinal number of the power set or the number of ordered pairs in the power set will be 3 into 3, that is 9, and if we count them 1, 2, 3, 4, 5, 6, 7, 8, 9, so it's correct. We have not missed any particular ordered pair. Now let us represent the relation as the set R. It is not the real number set, it is representing the relation set. Then it will be a subset or equal to the power set. We are defining a relation A to A. Now basically this relation will have a particular definition. So for example, let us consider the relation defined by x comma y belongs to R if x is greater than y. Okay, so x comma y, any general ordered pair will be an element of the relation R if x is greater than y, or the first term of the ordered pair is greater than the second term. So in this case, the R set will have the elements 2, 1, 3, 1, 3, 2. That's it. No other elements is satisfying this given condition or the given definition of the relation. So these are the only cases or only 3 elements of this particular relation R. So we can conclude that relation is a non-empty subset of A cross A. Since the examination is going to be of MCQ type, then this term plays an important role. We must know how many subsets are possible from a particular set. Suppose a set A, the cardinal number or the number of elements is n. Then number of subsets is given by the formula 2 to the power n, which includes the phi or the null set itself. So this 2 to the power n counts all the possible subsets out of a particular set with cardinal number n. For example, if we take a set A as 1, 2, then the possible subsets are 1, 2, 1, 2, and the phi. Phi is the universal subset. So in this case the cardinal number is 2 and the total number of subset is 2 to the power n, that is 2 squared, that is 4. Any relation can also be represented in Venn diagram format. Suppose this is the set A and this is the set B. So suppose these dots represents the elements of the set A and these dots also represents the elements of set A. And by a particular definition, this element is related to this one, this element is related to this one, this element is related to this one, and there is no such relation, or the definition is not covering this particular element and this particular element in both the source and the destination set. All these related elements are named as the pre-image and image. This particular set is known or called domain, and this particular set is called codomain. Okay, and the elements that are the images of a particular pre-image in the domain set builds the set called range. Range is a set of all those elements that are satisfying the given relation or the satisfying the definition of the relation.